Okay, clustering homicide data to help police visualize problem zones, an analysis of the Washington Post homicide data. I'm Jeremiah Snipes, and thanks for joining me today. Um, the objective of this project is to identify potential clusters of homicide cases based on geography and demographics that show signs of being consistently uninvestigated. So we're using unsupervised learning, and I want to see if the data can reveal groupings of cases where solve rates are low. And if a cluster does exist, they could help law enforcement agencies understand where investigative resources or strategies might be falling short. A bit on the background contextually is over the last decade, the homicide clearance rates have declined in many major cities across the U.S., but not every community is affected equally. And what this means is some areas are often underserved or marginalized, and they may experience lower solve rates due to factors like limited resources. The community has some mistrust and systemic bias. So this project doesn't try to solve those problems directly, but it does aim to surface them through data in a way that could lead to better conversations and ultimately resource planning. Some more on the background and some of the data set itself is the data I'm using. I got it from the Washington Post homicide database. This is from Kaggle. It's got about 52,000 cases or unique values from large U.S. cities spanning over a 10-year period. This is 2010, 2020. It includes details on victim demographics. It even has geographic coordinates like latitude and longitude, and whether or not each case was actually solved. It's nice from Kaggle because it's already been cleaned. It's well documented, and it just makes it ideal for the clustering analysis I'm going to do. Some more on the background, but more specifically, the research gap here is so far most of the research in this area has focused on simple stats like clearance rates or race by city. While that's valuable, it doesn't tell us much about the interactions between variables or whether certain patterns repeat. And so I want to use clustering to dig a little deeper to explore whether certain combinations of factors are more likely to result in an unsolved case. So this is an exploratory approach, and really it just means I'm not starting with assumptions. I'm just going to let the data guide me with some of the patterns that I find as I dig deep over the next 72 hours. It wouldn't be a project without a hypothesis, and the main question I'm exploring is whether clusters of unsolved homicides exist and whether they're tied to shared traits. So, where the victim lived or where they were demographically. The null hypothesis here says no. That unsolved cases are spread randomly. And of course, the alternative hypothesis is that meaningful clusters do exist, and that cluster could help us identify and visualize them. Okay, some methods, and this is talking about some data and some of the features. I mentioned that the data set itself has 52,000 unique values, and these are actually homicide cases. They're drawn from the full data set, and so for clustering, what I did is I selected features like victim age, race, sex, and the city where the homicide occurred, and I mentioned before, but the latitude and longitude. Um, these are the factors that could reflect both social context and some of the investigation practices. For this effort, I'll be applying k-means clustering to a group of similar cases, and all analysis will be done using Python and some of the libraries that we've done in the weeks 1 through 3 with the pandas, skitlearn, and some of the matplot that we have. Okay, clustering and some of the visuals is Once the clusters are created, I plan to do a post hoc analysis to examine the clearance rate within each group. And what the goal here is, if some clusters show unusually low solve rates, this might suggest deeper structural problems or under resource areas, and that part's important. So to make this easier, and to ultimately interpret this, I'll use some PCA plots for visualization along with heat maps, and I'm going to try to throw in a bar chart or two to kind of break down some of the clearance patterns. And all of these tools will help translate the data into a format that's more accessible for both, if a real world, if this is a real world effort, this would help make this data more accessible for researchers and policymakers, because that's what we're doing here. We're trying to provide actual value. Okay, so onto the statistical approach. So this is an unsupervised clustering, and it's going to be centered on a k-means clustering. And this is a good choice because it can, I think, effectively sort some of the. It's a large data set, and so I want to sort this large data set into groups based on the shared features that I talked about. These traits, if you will. Just a reminder: the victim age, sex, race, um, and the Latin long in the city that I talked about. And so what I'll do is I'll compare the solve rates in each group to look for clusters that appear to be consistently underserved. That's a key word, to be consistently underserved. And again, this part is exploratory. I'm not assuming an outcome, but the tools are in place to reveal one if it's there. Okay, summary. So exploratory framing is what I like to call this. And so, really, to summarize, this project is still in progress, and it is built around a clear goal, but to use clustering to identify, these patterns in unsolved homicides, and if I'm successful, this approach could highlight what I'm calling problem zones and clusters of cases that seem to be falling through the cracks. And so the idea here is this could be incredibly useful for law enforcement agencies, and it could give them a way to proactively allocate investigative resources where clearance rates are the weakest, instead of reacting after the fact, right? We want to be proactive and not react. And so I'm going to use the data to guide these decisions and guide those decisions, which means we could eventually help make investigations more fair and more effective. Okay, thanks for listening. While the analysis is ongoing, I think this kind of exploratory work has a lot of potential. It shows how data science can help us make better questions and possibly find new angles on tough social issues. So I'm excited to see, ultimately where the clustering results lead me and what they might reveal. So I look forward to showing you the final product and the paper and getting any feedback. So thank you.